Today, we're going to look at the headless data architecture, what it is, why you would use it, and why it's becoming increasingly more popular in businesses of all sizes. The headless data architecture is the formal separation of data storage, management, and access from the services that process and query it. We call it a headless data architecture because of its similarity to a headless server, where you have your own monitor and keyboard to log in and access the server. If in a headless data architecture, you want to process or query your data, you're going to have to bring your own head, which we will talk about more here in a bit, and plug it into the data that we find below. Apache Kafka has long since had a headless data model. Writing events to Kafka is completely decoupled from consuming events. The producer service is one independent head. You could say maybe it's a Flink service, a Kafka Stream service, for example. And it's writing to this topic. Consumers are also their own independent heads. Maybe you're reading from Kafka to power an operational system written in Rust or Go, but maybe you're performing analytics on the stream or something else. While these Kafka topics offer streaming sources, which we're pretty familiar with, Apache Iceberg, a leading open source project, is beginning to feature heavily in the serving of tables in a headless data architecture. Iceberg is, in effect, a file system manager for columnar data, including the incredibly popular Parquet format. Iceberg provides several key features that enable table formats in a headless data architecture. The first is table storage. And this is the data, often stored in Parquet, that we would then write, say, to something like Amazon S3 or another cloud file service. Second is the catalog. And the catalog composes a number of different parts and has a number of different features, but these include functions such as metadata and metadata for the Iceberg service to know what tables are where, what's in them, what files belong to them, and so on. It also has information pertaining to schemas. What are the schemas of those files and of the defined tables? The catalog in Apache Iceberg plays a very big role in letting the processors, that we'll talk about shortly, and query engines plug into its data. A third feature of Iceberg is transactions. And so Iceberg supports transactions such that multiple heads can both read and write to the data at the same time. A little like Kafka, where you can write to a topic and many different consumers can read from it without affecting each other. Fourth is time travel, and this one's pretty neat. What it lets you do is it lets you visit what your data looked like at a certain point in time, say last week, last month, or maybe even last year. And to do that, it needs to access the metadata and know how those files are laid out and how to decide which files to include and not in the query. Iceberg provides this central data layer where we can then plug in our processing heads, such as the open source options, like Flink, Trino, Hive, things like DuckDB, and say Spark. Now, this is not a comprehensive list. There are many others. These are just some that will fit nicely on this board while we're having our talk. We can also plug in, though, other popular SaaS solutions, things like BigQuery, Athena for AWS, and even, of course, services like Databricks or Snowflake. How you integrate with these services vary, but it typically relies on, say, the Iceberg metadata catalog. And the processing heads that want to either query or process or write to these, this data needs to sync the metadata from the Iceberg catalog locally to some of its own catalog, or again, this will vary depending on your implementations, but it syncs that data there such that it knows easily where all the files are and how to go about querying them. So what are the main benefits of a headless data architecture? Well, one as I just alluded to, is that you don't have to copy data around anymore. And this saves you a ton of money and complexity. So if you're an AWS user, you can use the metadata to query, say, in Athena or Redshift or Snowflake. You're not stuck to any specific engine anymore. 2, you don't have to coordinate multiple copies of data either. So there's no more similar yet different data sets where they're almost right, but the other one isn't quite right. So which is the truth and which isn't? None of that anymore. You get a nice single set of data that you can then plug in wherever you want, and so they're all going to have access to the same data or not at all. 3, bring whatever head is most suitable for your job. Perhaps you want to use BigQuery for one, but you want to use DuckDB for another. Because your data is abstracted away from these processing engines, these heads, you're not stuck with one or the other. And there's no data lock-in because you're not stuck with any of these engines because you loaded all your data in there years and years and years ago. 4th, we get a single point of access control. Now this dotted line is doing a bit of the heavy lifting, but effectively what this means is you can control at your data level which services can access it. You can set very granular permissions or you can set wider, more wholesale permissions, but at the end of it, you don't have to configure permissions at the individual nodes. You can inherit that from the underlying layer. And it also acts as a sort of global kill switch in the case that you need to cut off all data to all services. I'm going to stop myself right here. A common question I get is, how is this any different from a data lake architecture? Well, I'm very glad that you asked that. And while there are many differences, there are 3 critical differences that I'd like to explore. Number 1, any service can use this data. It doesn't matter if you're using it for something like analytics or something perhaps more real-time or operationally focused. It doesn't matter. With a headless data architecture, the goal is about making data access easy and consistent and letting you choose the data you need to do your work. Number 2, you can use tables or streams or both. It's entirely up to you. Again, it depends on what you need it for, what your latency requirements are, what your processing requirements are. But the idea here is that by formalizing this modular data layer, you can compose your access to your particular business use cases how you need it. And number 3, because the headless data architecture does not require you to copy all your data to one central location, it lets you compose not just one data lake, but many smaller data lakes if you so choose. Again, you get the ability to plug in heads, and one of those heads may be a data lake. You can plug them in and gain access to whatever data you need, a little like data clean rooms. The only requirement is that you can serve a compatible API to those heads. Parquet with Iceberg, or something like Avro, Protobuf, or JSON schema with Apache Kafka. Many businesses today are building their own headless data architectures. And one of the most common things that we see is people using Kafka Connect to convert topics into tables. Usually looks something like this. We have a nice Kafka Connect connector. We read the data from the topic, and we write the data into this table. Now this connector's got a lot of work to do to make that happen. At Confluent, we've created a service that we call Tableflow to automatically streamline this process for you. It takes your topic and converts the events one by one into an append-only Iceberg table for you to then plug into whichever head you choose. And there's no more rote break fix work. All of this is fully automated. For clarity, in the short term, the Iceberg table that Tableflow creates remains a copy of the original data, but we're looking at ways to unify the table and stream storage to further simplify our headless data architecture. The headless data architecture formalizes the much needed separation of data storage and data processing. It saves you money, it reduces system complexity, it reduces copies of data, and it eliminates countless pipelines, and all of that break-fix work and monitoring that goes along with it. To make it a reality, you'll need to invest into your headless data layer. Apache Iceberg is an excellent candidate for building your tables, and Apache Kafka for your streams. Then you simply plug in whichever processing heads you need for your business use cases. You can manage your data from a single logical location, including permissions, schema evolution, and things like table optimizations. And to top it off, it makes regulatory compliance a lot simpler since your data resides in one place instead of being copied and passed around to every processing engine that would otherwise need it. Well, that's it for me today. I hope that you enjoyed this video and that you'll think about how a headless data architecture can work for you. If you like this video, I encourage you to please like and subscribe, and stay tuned for future episodes where I'll talk more about event streams, event-driven architectures, and how to build a healthy data ecosystem.